In the last lesson, we learned that atoms are building blocks of matter, which means matter are made up of atoms. Many atoms put together, you get matter. Just like cells are building blocks of organisms, organisms are nothing but a collection of cells. Same way, matter is a collection of atoms. So atoms are a building block of matter. Now, in an atom, there are positive as well as negative charges. You have the positive charges as well as negative charges. And the atom on the whole is neutral because the positive and the negative charges are equal. You will learn this more in detail in the next chapter. But for now, it's enough for you to remember that atoms are neutral. They are made up of charges, but they are neutral. Now, atoms usually exist in two forms. They sometimes exist as ions and sometimes they exist as molecules. You usually don't find atoms existing on their own. However, there are a few atoms that exist on their own, and those atoms are the atoms of rare gases or noble gases. And the examples of this is like helium. And helium atom will exist on its own, just on its own this way. You have helium, you have argon, xenon, krypton. These are noble gases, and all these atoms just exist on their own. They all exist as a single atom. But all the other atoms usually exist as ions or as molecules. Now we'll go in detail and find out what are ions. So we have earlier learned that atoms are neutral, but they are not stable. Why they are not stable also we will learn in the next chapter. So most of the atoms are not stable. Not all atoms, most of atoms are not stable. So here atoms are neutral and most of the atoms are not stable. And in order to attain stability, the atoms then gain or lose electrons. If an atom gains an electron, remember, electron is negative charge. So when it gains an electron, it becomes negatively charged because it has now extra electrons. And such an negatively charged atom is called an anion. But there could be a case when sometimes atoms lose electrons. Lose electrons means they lose a negative charge, and if they lose a negative charge, they become positively charged. And such positively charged atoms are called cations. So atoms with a charge are called ions. Now the charge could be two, positive or negative. A negatively charged atom is called an anion, and we already learned how an anion is formed. An anion is formed by gaining of electrons. An example of anions is like oxygen. It has got -2. Then you have chloride ion, -1, iodide ion, -1. And a positively charged atom is called a cation, and we know how cations are formed. Cations are formed by losing of electrons. An example of cations is like magnesium +2 or maybe sodium +1. They all lose electrons. Now why do some atoms lose electrons while others gain electrons? That again will be clear in the next chapter of structure of atom. So here we have learned that atoms usually do not exist on their own, The only atoms that exist on their own as single atoms are those of noble gases. But atoms usually exist as charged particles called ions. Some are positively charged and they are called the cation. Some are negatively charged and they are called the anion. So we saw that atoms exist in two forms as ions and molecules. Now let's tackle molecules. So atoms also exist as molecules. Now what are molecules? Molecule is a group of two or more atoms. Let's take some examples like a molecule of water. This is H2O. This is a molecule of water, which is made of 2 hydrogen atoms plus 1 oxygen atom. Or you could have a molecule of carbon dioxide, a group of atom, molecule of carbon dioxide. Here again, if you see, it is made up of 1 carbon atom plus 2 oxygen atoms. So molecules are nothing but a group of atoms. Now these atoms that stick together, they stick together by bonds of two types, ionic or covalent bond. That you will learn later. But remember, the atoms in a molecule are bound together by bonds. So here we said atoms in a molecule are bound together, are kept together, are bound together by bonds. Like here you have a molecule of water which is made up of 2 hydrogens and 1 oxygen, and they would be bound together or stuck together by these bonds. Of course, the bonds are of two types, which you will learn again in the next chapter or maybe next year. So molecules are held together by bonds. Now molecules are of two types, molecules of an element and molecules of a compound, and let's go to see the difference between them. To know the difference between the molecules of elements and molecules of compounds, let us take some example of elements. Like oxygen is O2, then we have chlorine, which is Cl2. We have hydrogen, which is H2. We have ozone, which is O3. So you have noticed that in oxygen, which is O2, is made up of 2 atoms of only oxygen. Then chlorine, which is Cl2, is made up of 2 atoms of just chlorine. Then we took the example of hydrogen. A hydrogen molecule is H2 and is made up of 2 atoms of only hydrogen. We took another example of ozone, which is O3, and it is made up of 3 atoms of oxygen. So if you go through all these molecules of element, the molecules are made up of same type of atoms. So molecules of elements are made up of same type of atoms. Now for compounds, example of compound would be carbon dioxide. It is made up of 1 carbon and 2 oxygen atoms. Or we take water, is a compound made up of 2 hydrogen atoms plus 1 oxygen. Let us take sodium chloride, that is a salt that we eat. It is made up of 1 atom of sodium plus 1 atom chlorine. By now you would have guessed that molecules of compounds are made up of different types of atoms. So molecules of elements are made up of same type of atom, and molecules of compounds are made up of different types of atoms. So now to recap, molecules of elements are made up of same type of atoms, like we saw oxygen, chlorine, ozone, and molecules of compounds are made up of different types of atoms, like water, like sodium nitrate, different types of atoms. We'll now learn about atomicity. Atomicity is the number of atoms present in a molecule. The first example is argon. Now, in argon is said to be monoatomic because it is just a single atom. So it is monoatomic. Then next is helium. Helium also is made up of just one atom, and hence it is monoatomic, a single atom. Atomicity is 1. Here also you can say atomicity is 1. Next, oxygen. Oxygen we know is O2, so it's made up of 2 atoms. 2 atoms means it is diatomic. Atomicity 2. Then next we have hydrogen. Hydrogen we know is H2, made up of 2 atoms, and hence diatomic. Atomicity 2. Then nitrogen, N2, made up of 2 atoms, 2 nitrogen atoms, so diatomic. That is 2. Atomicity 2. Chlorine. Chlorine atom is Cl2, which is made up of 2 atoms. 2 atoms means diatomic. Atomicity 2. Now phosphorus is P4, means each molecule of phosphorus has 4 atoms of phosphorus. And if you say 4 atoms means it is tetraatomic. Tetra means 4, atomic. Atomicity 4. Now for sulfur is S8. Anything more than 4 is called polyatomic. It's got 8 atoms. One molecule of sulfur is made up of, is a group of 8 atoms. 8 atoms together of sulfur make one molecule, and this is called polyatomic. Atomicity 8. Next is sodium. Sodium is 1 atom and it is monoatomic. Then iron, 1 atom, also monoatomic. Aluminium, 1 atom, again monoatomic. Then copper, also 1 atom, monoatomic. All monoatomic, 1 atom, so you can say it is atomicity is 1. Ozone is O3. O3 means 3 atoms of oxygen makes 1 molecule of ozone. 3 atoms, so this is triatomic. Atomicity will be 3. Calcium hydroxide. Now the formula for calcium hydroxide is CaOH twice. So it has got 1 calcium plus 2 oxygen. Say oxygen, 2 oxygen plus 2 hydrogen. So the atomicity will be 1 plus 2 plus 2, which is 5. Next is hydrochloric acid, HCl, made up of 1 hydrogen atom plus 1 chlorine atom. 1 plus 1, atomicity 2. Sodium oxide. Sodium oxide is Na2O. So it is made up of 2 sodium atoms plus 1 oxygen. 2 plus 1, atomicity 3. Then next, aluminium hydroxide. Aluminium hydroxide is OH twice. So this is made up of 1 aluminium plus 2 oxygen, oxygen 2, plus 2 hydrogen. So that is 1 plus 2 plus 2, atomicity 5. Next, sodium hydroxide. NaOH is sodium hydroxide, made up of 1 sodium atom plus 1 oxygen atom plus 1 hydrogen atom. So 1 plus 1 plus 1, so that is 3, atomicity 3. Potassium nitrate. Potassium nitrate is NaNO3, made up of 1 sodium plus 1 nitrogen plus 3 oxygen. So 1 plus 1 plus 3, and that is atomicity 5. And then we have ammonium carbonate. Ammonium carbonate is NH4 whole thing twice, CO3. So here if you see, there are 2 nitrogens, there is 4 into 2, there is 8 hydrogens, 1 carbon plus 3 oxygen. See, this whole thing is 2. So there will be 2 nitrogens, and 4 into 2, 8 hydrogens. So when you add up all this, you get 2 plus 8 is 10, 11, 12, 13, 14. Atomicity 40. So atomicity is a number of atoms present in a molecule. Next we'll define what is a polyatomic ion. A group of atoms carrying a charge is called a polyatomic ion. Example, carbonates, CO3 minus 2. It has got a group of atoms. It has got carbon and 3 oxygen, and it carries a charge. So this is a polyatomic. Sulfate, SO4 minus 2. Group of atoms carrying a charge. Or we can say nitrate, NO3 minus 1. A group of atoms carrying a charge. And ammonium, NH4 plus 1. A group of atoms carrying a charge. So that is a polyatomic ion. You can get it from the word only, polyatomic ion. What is meaning of polyatomic? Means many atoms, a group of atoms. Ion means carrying a charge. So a group of atoms or many atoms, you can say group of atoms or many atoms carrying a charge is called a polyatomic ion. In this list of compounds, let's write the formula and the elements present in each. Like water, the formula for water is H2O, and the elements present are hydrogen and oxygen. Next is carbon dioxide, CO2 is the formula. Elements present is carbon and oxygen. Next is ammonia. Sulfur dioxide is next. So SO2 is sulfur dioxide. Elements present sulfur and oxygen. Then we have ammonia. Ammonia is NH3. Here I want to bring to your notice difference between ammonia and ammonium. NH4 is an ion, and that is ammonium. NH3 is a gas, and it is called ammonia. So ammonium is NH3. The elements present nitrogen and hydrogen. Then next we have methane. Methane is written as CH4. Elements present carbon and hydrogen. Next, ethanol. Ethanol is a kind of alcohol. So C2H5OH. Elements present carbon, hydrogen and oxygen. Next we have hydrogen chloride. which is HCl. Elements present: hydrogen and chlorine. Next, carbon tetrachloride. Carbon tetrachloride means 4-chlorine, tetrachloride. Elements present: carbon and chlorine. Hydrogen sulfide. Hydrogen sulfide is H2S. Elements present: hydrogen and sulfur. Then we have carbon disulfide. Carbon disulfide. Di means 2, so 2 sulfide. Elements present: carbon and sulfur. Next, we have quicklime. Now, quicklime is calcium oxide, and you need to remember this. Elements present: calcium and oxygen. Next, hydrogen bromide, that is HBr. Elements present: hydrogen and bromine. Br is bromine. Next, baking powder. The baking powder is sodium hydrogen carbonate. So elements present are sodium, hydrogen, carbon and oxygen. Then we have potassium sulfate, which is K2SO4. Elements present: potassium, sulfur and oxygen.